Section 1.7, number 12. We're given a function f of x is the quantity x minus 1 divided by 4. We're supposed to find the inverse informally. I'm not sure what that means. I'm not wearing a tie, so I think I'm good there. And verify that f and f inverse leads to x, and f inverse of f also leads to x. Okay, so to find our inverse, we set up essentially an equation of the graph y equals our x minus 1 divided by 4. And then solve for x in terms of some f inverse of y. Okay? Mangled letters included. Okay, so we have this division by 4 and this subtraction by 1. So if I clear out that 4 first, I multiply both sides by 4, leaving 4y is equal to x minus 1. And then if I add 1 to both sides, I will get this canceling out there, leading us to x is equal to 4y plus 1. Now, it wants it written as f inverse of x, but x and y's are just placeholders. They indicate which sets our numbers come from. So f inverse of x is we replace the y with an x. Okay. So there's my inverse. Now, it says next I want to verify that f of f inverse leads to x. Okay, which means that f inverse means that everywhere where there was an x in our original f, we place the entirety of f inverse. So it's f of 4x plus 1. So everywhere where there was an x, we now put a 4x plus 1. Then we still have our minus 1. We still have our division by 4. Okay? All right. Simplification is the way to go. We're going to have this parentheses doesn't do much since it's addition, and addition is associative, so it doesn't matter what order you do it. So the plus 1 and the minus 1 are going to cancel, leaving us with a 4x over 4. Okay, but we're multiplying by a 4 and dividing by a 4, so they'll end up canceling out, leaving us with an x. So we're good with the f of f inverse. And for the f inverse of f, okay, so it's going to be f inverse of the entirety of f of x, x minus 1 over 4. Okay, so everywhere where there was an x in our f inverse, we stick our entire f. All right, so we're going to get 4 times x minus 1 over 4 plus 1. Okay, now we're multiplying by 4 and dividing by 4, so those pieces will cancel out. We're leaving us with an x minus 1 left over from our original piece, adding 1. Well, if we're adding 1 and subtracting by 1, those pieces will cancel out, leaving us with an x. Okay, so this thing is verified. We now have an f and an f inverse. Verified. And we're done.